Hey everybody, so I'm just going to go through two of these questions here in this video from the questions on page 21 of Physics Plus. So the first one is going to be question 8, and then after that we're going to go on to question 11 as well, and just recap over that too. So question 8 talks to us about a dentist. He uses a curved mirror to see an upright magnified image of a tooth. So what type of mirror would she use, convex or concave? If it's an upright image, well, that could be a convex mirror or it could be a concave mirror. But if it's upright and magnified, then it has to be a concave mirror. So what that would look like is we'd have a concave mirror like this, and the object would be inside the focal point. So this will give us an upright image and a magnified image. If we used a convex mirror, we would get an upright image, but we would get a diminished image too. So if we go on to the second part of the question, if the mirror has a focal length of 5 centimeters and it is held 15 millimeters from the tooth, what would be the magnification? So I see one trick already here is that they've given me the distances in two different units. They talked about 5 centimeters and 15 millimeters. So before I stick either of these into any formula, I just have to decide which unit I'm going to use. My preference here would be to use centimeters, so I'm going to put this as 1.5 centimeters because there's 10 millimeters in a centimeter. I'm just going to divide by 10. If you're not sure whether to divide or multiply, my advice is just try doing both. You can see that one of them will give you 150 centimeters and the other will give you 1.5 centimeters. So 1.5 is probably more realistic as a conversion, so I'd stick with that one because we know that our 15 millimeters will be smaller than 5 centimeters. So now we look at what they're actually asking us for, and that will be the magnification. There's two formulae for the magnification. There's the magnification is equal to the image height over the object height, and there's that the magnification is equal to the image distance over the object distance. So if we're going to get the magnification, chances are we're going to have to use one of these formulae. Now we're not given an image height or an object height, so it looks pretty unlikely we're going to have to use this one. So I'm going to get rid of it. But we are actually given, we're given the object distance here as being 1.5 centimeters. So if we have the object distance, in theory, if we could find the image distance, if we could find V, then we will be able to find N. So I'm just going to draw a little box around this formula and we're going to come back to it later once we see if we can figure out what this V value is here. Because again, we know U. If we know V, then we can solve it for N because we can divide V by U. So let's have a look at what we do know now other than U. So we have U is equal to 1.5 centimeters. And we have V is unknown. And we know that the focal length, I think we're told the focal length, yeah, it's 5 centimeters. Okay, so if we're trying to find V, again, to fill it into this formula, we already know U, we're trying to find V. So we can divide V by U to get in. If we want to find V, I know a formula that will help us out. It's the only other formula we know for mirrors. It's 1 over F is equal to 1 over U plus 1 over V. So we can fill in what we know. We've got 1/5 is equal to 1 over 1.5 plus 1 over V. Rearranging this a little bit gives us 1 over V is equal to 1 over 5 minus 1 over 1.5. I'm going to solve this using decimals because it is the most convenient way for me at the moment, but you can solve this out whichever way you like to try and just get one number. 1/5 is 0.2 and 1 over 1.5 is 0.667. I could use way more decimal places if I wanted to. If you're not sure how many to use, just stick with 3. Now I'm ending up with a negative value on this side, which might be pause for me or cause for me to pause and think about whether or not that makes sense. So if I end up with a negative value for V, my image distance, would that make sense in this question? And actually it would, because the image is behind the mirror, so it's a virtual image. And that means we're going to have a negative V value. So I'm happy enough to keep going with the question now at this point. So I can put this over 1 and I'll cross multiply. 1 times 1 and V times 0.467 minus 0.467. So you get minus 0.467 V is equal to 1, and then V is equal to 1 over minus 0.467. This gives us a distance for the image of minus 2.141 centimeters. Now, I'm very happy with my work here. I've figured out what the image distance is. I'm just going to go back to the question and check that I've actually done what was asked. So the question is saying, if the focal length is a mirror of 5 centimeters and is held 15 millimeters away from the tooth, what will be the magnification? So it's a good idea to just check that we've actually solved what the question has asked us for, because now I remember, yes, I was trying to find the magnification originally. So I'm going to go back to this formula. I'll probably rewrite it out, but I'm not using a normal sheet of paper. I'll rewrite it out over here maybe. So magnification is equal to V over U. Remember, if you're doing a question like this, just write it down beneath. You're not cramming it over to the side like I am here and explain everything. You want it to be nice and linear so they can follow your logic. Okay, so M is equal to V over U. We know that V, our image distance, is equal to minus 2.141. And we know that the object distance is 1.5. So the magnification that we get is minus 1.427. I'm pretty sure the back of the book says the magnification is 1.427, because the magnification really, the ratio of the size of them is 1.427. The image is 1.427 times the size of the object, 1.4 something times bigger. But the reason why it's negative is just because of that image being virtual. So the magnification, it's got a virtual image distance over real object distance, so it's going to be minus over positive. So that's the significance of the minus sign here. It is still bigger, the image is still bigger than the object, but the minus just means that it's a virtual image. Okay, so as I said, we're going to move on to question 11 now. This one is just, I guess, conceptually quite hard, because you need to pretty okay at visualizing what's going on with the difference between plane mirrors and concave mirrors. So they say an object is placed 10 centimeters in front of a concave mirror and inside the focal length. When the concave mirror is replaced with a plane mirror, the image moves 15 centimeters towards the mirror. Find the focal length of the concave mirror. So this diagram here will represent what's going on. If you're not sure what to do in a question, a lot of the time, one of the best strategies is just to draw a diagram, and it'll help you kind of sort through your thoughts. So it's placed inside the focal length. Let's give ourselves a focal length here. We don't actually know what it is. We've got an image here. Just going to label that I. And then we have an object. And then the image on the far side, right? If this is 10 centimeters, there's another detail we have. If the mirror was a plane mirror, then the image, right, the reflection would be right here. Right, that's where the image would be if it was a flat plane mirror that just went straight down like this. Right, the object distance and the image distance will be the same. But it's not, it's a curved mirror. So the actual location is going to be another 15 centimeters away from the mirror. So I'm going to add another 15 centimeters on. And this is where our actual image is. So again, if we set it up with the curved mirror, then the image is over here. If we get rid of the curved mirror, then it'll move 15 centimeters. The image moves 15 centimeters closer to the mirror if we're using our plane mirror instead. So it's out here if we have a curved mirror, it's in here if we use a plane mirror. Okay, so now having drawn that diagram, I know that the object distance is still 10 centimeters. But now I also know that the image distance is minus 25 centimeters. That's gotten by adding 10 and 15. Because the image is virtual, it's on the back side of the mirror, I'm going to use minus here because the distance is minus. This side is plus, it's a minus if it's behind the mirror. And they want me to find the focal length of the mirror, so I'm going to use now my formula 1 over f is equal to 1 over u plus 1 over v. Then I fill in my values for u as being 10 centimeters and v as being 25 centimeters. Again, because the v is virtual, our image distance is virtual, I'm going to make that minus, right? So this minus outside here represents that. If anybody is unclear about why filling in a minus down below equates to a minus outside here, please just let me know, and I'm happy enough to talk you through it in a little bit more detail. So now if we get a tenth and we take away 25th, you can do it in your calculator, you get 6 over 100. I've done that out longhand using fractions here in my rough work. So then the focal length, we can invert this. It'll be 100 divided by 6. Again, you can use your calculator if you like. The method is just going to be the same as I used there at question 8. And then you get 16.667 centimeters as your answer.